I know this is what you came here for, really. I need some of that caffeine shampoo. You told me that a little bit late. Cool. Okay, so kia ora koutou. Thank you for that introduction. I'm going to talk to you about soil biodiversity. Who's ever thought about soil biodiversity here before? Put your hand up. More than I thought. Okay, great. So I did originally call this talk Dishing the Dirt on Soil Biodiversity because I didn't really know what I was going to talk about. And then I had that sort of esprit d'escalier moment when I realized I could have called it Sex, Bugs and Rocks to Roll. So let's pretend that that's what I actually called it, okay? Okay, so I am a soil ecologist, which means that I look at life in the soil. I don't just whip my massive pink worm out for anybody, but you're all discerning audiences, so I thought I'd treat you tonight. I'm also a macro photographer, so I take photographs of all of the stuff that lives in the soil and I use it for soil communication, and so a lot of the photos that you see tonight are mine unless otherwise credited. Hopefully I remembered to credit them. Okay, so only dry slide, I promise. So soil is a massive biodiversity reserve. We should care about life in the soil because at least 60%, probably more, of all the species on Earth are found in the soil. And they're really important. All the things, the interactions they do, give us food, give us water, give us building materials, really important. But they don't have an easy time of it in the soil. Loads of challenges they have to overcome, and that's what we're going to talk about tonight. So there's environmental challenges from extreme weather. They have to eat but not be eaten, and they have to get around somehow. And they also have to find partners for reproduction. And I'm going to be completely honest with you, the back half of this talk is going to drop the bar really low because it's mostly about reproduction of soil animals. There's going to be earthworms. I know that's what you came for. So anyway. But I'm just going to pick out a few exemplars of how things survive in the soil. So, who knows what a tardigrade is? I'm assuming everybody. Well, most of you. Awesome. So, tardigrades, the German name is Kleiner Wasserbär. It means little water bear. That's the person who discovered them was German. And they do look a little bit like bears. Genetically, interestingly, they've actually lost the middle section that arthropods have. They're actually just a head and an anus bolted on together. But they are incredible for their ability to do this thing called cryptobiosis, which means they essentially hunker down, they shrivel up, they crystallize their internal structure, and they can get through anything, and I mean anything. So there's actually a colony of tardigrades on the moon at the moment. Scientists like to chuck them into space to see what happens, because they're the only animal that can survive that. In fact, the first time they were thrown into space, they were exposed to solar radiation, they were brought back in, and then the females just gave birth like nothing had happened, and it was fine. But scientists like to freeze them and do weird and freaky things to see how far we can push their tolerance. So top right here is Westlake University in China. Scientists actually froze them to almost true zero, and then they went to sleep, and then they gave them a tattoo. And it was the Westlake University tattoo. So these are like, you can see the scale bar here, but that does mean, and this is the best joke in the entire talk, so please enjoy this, humans are not the only animals that have woken up with a tattoo and no memory of the event whatsoever. Thank you. They have also been quantum entangled, so they've been frozen and put into a quantum computer, quantum entangled with 2 qubits, and then they woke back up and they were absolutely fine, so they're the first animal to claim to have been quantum entangled and survived. And to find out if they survived the crash landing on the moon, because they were in a space shuttle, a space capsule that crashed unintentionally and scattered them on the surface of the moon, they have also been fired out of guns, special tardigrade firing cannons. And they found that at the velocity of that impact, they probably did survive. So there we go. They're just waiting to get their own back. If the moon ever gets an atmosphere, we're in trouble. Okay, so that's overcoming environmental extremes. How about finding food? So in soil, it helps if you can diversify your menu, and nothing is better in the soil at finding food than the mites. Who knows what a mite is? An arachnid? Yeah, nice. Very informed crowd, I should have known. Okay, so on the left here, that's a parasitic mite that's feeding on the blood of another arachnid, a harvester. That's pretty mainstream as far as mites go. On the bottom right, there is a slug mite. They spend their entire life feeding in and on slugs. So they feed on the blood and the mucus of slugs, and they actually reproduce inside the lungs of the slugs. And the slugs can't get rid of them, and if they ever walk off the slug, then they'll just follow the trail of slime back to the slug and find it again. So they can't get away. So they must always feel itchy, I imagine. Who knows what the thing in the middle is down the bottom here? Demodex, yes. So I hate to tell you, but there is actually hundreds of thousands of mites with us in this room because these live on your faces. And they live inside the pores where you have hair follicles, and they eat this thing called sebum, not semen, sebum, which you produce out of your face all of the time. Okay, I'm going to throw this one out to the audience. What is the fastest animal on Earth? Cheetah? Okay, whoever said cheetah has to do 2 fingers of your beer. It is actually a mite. So relative to body size, cheetahs can run 16 times their body length per second. How fast do you think that one of these mites can run? So this is an American type of whirligig mite. How many body lengths per second? 322. So it's the equivalent of a human outrunning a jet airliner, essentially. So they're pretty fast predators. Nothing stands a chance when they're trying to get them. Okay, so that's getting food. What about not becoming food? So again, mites are kind of the masters of this in the soil. So this is the Hellraiser mite. I named that. So it's saying, don't eat me, it's covered itself in spines. There are other alternative methods, though. So who can see the mite in the top left? Can you see the mite? Because this mite is apparently a master of camouflage. It has effortlessly placed a bit of soil on its head, and that is camouflage for a mite. It seems pretty happy with the job. And then bottom left, the alternative is if you can't hide and you can't grow spines, then you can also just tank up. And so this type of mite is pretty special, actually. It can pull its legs into its body, and then its head is an armored flap, which it can then close, and it completely seals itself off, so there's nothing for predators to get. Bottom right is a springtail. So the thing that looks a bit like its penis, that's poking through. That's actually the spring in springtail. So this is its jumping organ. So it slams that into the ground when it's disturbed, and faster than you can blink, they launch themselves up to 100 times their length in height. That's the equivalent of a human jumping over the Eiffel Tower in a split second. So pretty impressive. And then before we get on to the sexy stuff, the last one is movement. How do you get around in soil? Soil is a challenging medium to get around in. Okay, so when it rains and you see earthworms crawling over the surface of the ground, why are they doing that? They don't want to drown? Okay, another 2 fingers of your beer for you. They're fine in water. They breathe through water. They can live for days in water. It's absolutely fine. It's actually they're just trying to move to somewhere new, and it's easier to move above ground than below ground. But they don't do it normally because they'll dry out. Earthworms are really prone to drying. So you learn something. So next time you see them all crawling, you just chuck them into the grass or something. They'll be perfectly happy. Okay, if you can't do that, a lot of small things like this pseudoscorpion and a lot of mites do a thing called foracy, which is hitchhiking. So this pseudoscorpion, they're related to true scorpions, they just haven't got the tail. That's hitching a ride on a fly. And there's actually been pseudoscorpions found hanging onto flies that have been intercepted over the Atlantic Ocean in flight traps. So they can actually travel across continents by doing this. So it's a pretty effortless way. They've even been found on animals and eating stuff as they go, getting in-flight meals as they're doing it. On the right here, this is a slime mold. So slime molds are incredibly efficient movers, and humans have used this to our advantage. So this slime mold is actually a single-celled organism. Doesn't look like it. It looks like a big thing. That's actually one cell, that thing, and they can grow about that big. And it's spreading out over a log in search of food. When it finds a bit of food, it will actually kill off all of the nodes that go back to the main body except the one that's got that bit of food. And in that way, they build the most efficient routes across their environment. And humans have used this to improve our own networks. So the GIF on the bottom right, that's actually showing the wider Tokyo region, and it was recreated with slime mold technology. So that's the rail network across Greater Tokyo. And all of the little bits of oat that they've put down are the main civilization hubs, the main towns and cities. And actually, within 5 days, replicated perfectly the human-built, which took a decade, by the way, a human-built rail network within 5 days. And it's been used to improve networks everywhere. According to Slime Mold, the M6 motorway in the UK, where I'm from, shouldn't run up the west coast. It should actually go over to the east coast and go up. But I don't think they're going to divert it based on slime molds. They've even been used to map dark matter in our universe. Effectively. And my personal favorite is they've been used to find the most efficient route out of an IKEA showroom, presumably by some disgruntled dad scientist who had enough. Okay, you put up with that. We're going to move on to the slightly dirty stuff now, so I apologize if the bar gets a bit low. Reproduction is the other major challenge. How do you find partners in soil, and how do you make use of that? So, lessons in Love from the Soil. We'll try and pull out some lessons here. Maybe you can take some of this home with you. Okay, so this is a springtail. We saw those earlier. The way the springtails mate is they use this thing called a spermatophore, which is this object on the left. So spermatophores are essentially a blob of semen on a stalk. So kind of cum-flavored lollipop, if you like. And, and so what they do is the springtails, the male springtails will leave those dotted all around the place. And when a female springtail comes across, she will assess the provenance. I don't know what quality she's looking for. And if she likes it, she will sort of straddle it and be fertilized and all's well. The tricky bit is when a male springtail comes along and finds a rival male spermatophore. What do you think he does? He eats it. Of course he eats it. That's good. It's nutrient rich. It's good stuff. So he'll use those nutrients to make his own spermatophores, but also he's taking the other male out of the running, and he'll leave his own spermatophores behind. On a similar note, this is another type of mite called a red velvet mite. Love is like a garden. You just tend to it and watch it grow, right? Unless you're a red velvet mite, in which case love is very much like a garden, because they build these incredible structures which we call love gardens. So male red velvet mites will try and entice females to mate with them by building this incredible structure which out of litter, so leaf litter and debris and stones and things, which they naturally glue together with their semen. And they all build this incredible structure. And once they're happy with it, they make a silk line, and they'll walk down this path, and they'll stand at the end, and they'll just be very patient. They'll wait. And when a female red velvet mite comes along, they'll sort of do a sexy little dance. And if she likes what she sees, then she'll follow them. He'll lead her down the garden path, if you will. And if she likes his sort of jizz fortress that he's built, then she will plonk herself down onto this puddle of semen that he leaves in the middle, and she'll just sit there and fertilize herself, very, very happy. And it's romantic. It's romantic. Unless, of course, a rival red velvet mite comes across an unguarded love garden, in which case he will promptly trash the place, he will rip it up, and then he will ejaculate over everything, just in case a female does come by and decides to sit down. So, not that romantic, perhaps. Okay. Possibly the least romantic of the soil invertebrates, though, are the symphyllans. So these are relatives of centipedes, and the males and the females never really meet, probably, and that's possibly for the best. So the males are the most least effort lovers you've ever heard of. What they will do is essentially they'll see an area of ground that they think looks good, and they will ejaculate onto the ground. And then they will go off and get on with their day, and they won't think much about it. And then a female will later come along, and they'll see the spermatophore, and she'll do what any red-blooded female symphyllan would do. What would you do? You would suck it up into your mouth and store it in your special spermatophore pouches that you have, and you would go home, and then she licks the semen or the sperm onto her eggs and fertilizes them that way. And so maybe it's for the best that they never meet, I don't know. Yeah. Maybe some people in the audience here can sympathize. Okay, I told you would learn about earthworm sex, and I will deliver. So earthworms, the lesson we can probably get from that is to always, leave your options open. The way that earthworms mate, at least the ones that come to the surface, is they 69, and because they're both male and female at the same time, they're hermaphrodites, and they will leave some of their tail segments back in their burrow, so they've always got a foot out the door, if you like. And then not if a better opportunity comes along, but if anything else comes along to disturb them, they can snap back and they can retreat back into their burrow really quickly and live to copulate another day. Earthworm sex is distinctly messy, though, as you can probably see in this image. They both have male parts, and essentially they will sort of come on each other's chests, and then they have a special channel that runs down the middle, and then it will sort of move up and down, and they will store their partner's sperm in special pores on their body, and then when they go back to their burrow, they'll use that sperm to fertilize themselves. So, yeah, it's kind of nice. It's like an adult cuddle. There you go. Okay, a couple more things. So this is a banana slug. Who's heard of a banana slug? Yay, a few. Do you know what the species name of banana slug means? It means long penis, essentially. And that is because It's quite a base talk, this, isn't it? Sorry. Really, the next one will be good, don't worry. So banana slug penises are about the same length as their body, which it sounds great, right? And they're both male and female, so at the same time, they're hermaphrodites too. But the problem with having an extremely long penis is that it can sometimes get stuck in places you don't want it to get stuck. So when banana slugs will mate with each other, they penetrate each other because they've got both male and female parts. But quite often, the males will get their penis jammed inside the female. It can go too far, or it's taken a right turn when it should have gone left or something, I don't know. But they'll get stuck. And they have no choice but to, if they can't pull it out, chew it off. So it's very common to see among banana slugs that either the recipient of the member, perhaps in anger, or the depressed owner of the member, chews it off and leaves it stuck in the hole. It's not all bad though, but because they're male and female at the same time, the one that's lost its phallus can still function as a reproductive female. So they can go on to, And the one that's received the member, it's stuck in there, it acts like a plug, and so it stops other males from fertilizing those. And originally they thought they were doing it intentionally to do that, but they weren't. They were really trying to get it out first before resorting to that. Thought I'd run out of time. Okay. I've got 2 more slides. Okay, next lesson. It's okay to be picky in your partner. Feel free to be selective. So this is I'd call it a woodlouse. You probably call it a slater, I guess, here. Yeah, there's actually about 100 regional names for them in the UK. Chucky Pig and Granny Grunter and all kinds of weird stuff. Roly-poly. So this one's glowing purple because it actually has an STI. So it's got a thing called an iridovirus, which is building up viral particles in its skin, in its muscle, and making it glow a beautiful purple. Unfortunately, that will eventually kill it, but that is not the STI that we're here to talk about. There's this bacteria called Wolbachia, and what Wolbachia likes to do is transmit through the female lines of invertebrates. And so quite a lot of woodlice are actually infected with Wolbachia virus, but it hates males because it likes to reproduce it only goes down through the female line. So if you're a male woodlouse and you go to reproduce with an infected female and you contract Wolbachia, one of 2 things is going to happen. Either the Wolbachia is going to kill you outright because it doesn't like males, or it's going to turn you into a female. So they can actually feminize the woodlice and turn them into reproductive females. So they're forced to undergo an involuntary sex change, effectively. And so for that reason, quite a lot of woodlouse populations are exclusively female. And then those females are just cloning themselves and producing more infected females. And that's how it goes. So next time you see a woodlouse, just have a bit of sympathy, because they're going through quite a lot right now, especially if it's a male. So there we go. Anyway, finally, my last thing I want to impart to you, the last lesson from soil animals is, above all, love yourself. This is a type of mite, and they called it a Platinophorus peltifer. It is an orobatid mite. It's one of those ones that armored up that we saw earlier. The interesting thing about Platinophorus peltifer is that they've been loving themselves for about 100 million years. In that, there hasn't been a male Platinophorus peltifer since before the T-Rexes walked the earth. So in 100 million years, they've been exclusively female. Presumably around that time, they've decided males were just a bit too much aggro and just just gave them the boot. And since then, they've just been cloning themselves and sisters doing it for themselves, right? And nary a man has been found. Anyway, that's all. Thank you very much. I'm sorry to bring the bar down a little bit. But yeah, I'm happy to take any questions.
Any questions? Okay.
Hi.
Hey.
Do you have any interesting invertebrate pickup lines?
Apart from showing my massive pink worm that I did. No. I don't think any entomologists don't really pull, so I don't think that's ever been done. There's a few at the back, actually. I should be careful what I say. There you go.
Okay, I have one.
Okay.
Can earthworms self-fertilize?
Yes. Yes, they can. So actually there's there's quite a few species that clone themselves, or they go through parthenogenesis, which essentially means they self-fertilize. Interestingly, so earthworms are quite often used for as model organisms for like ecotoxicology studies. So if you've got like a soil pollutant, a lot of the standards are you mix it in some soil with some earthworms and you kind of see what happens. You see if they die, how quickly they die, when do half of them stop dying. The problem is, whoever came up with that didn't know anything about earthworm ecology, because they actually put forward a compost earthworm that doesn't live in soil, for a start, and also ones that sexually reproduce, when there are plenty of soil-living, self-cloning earthworm species out there. So if they actually knew what they were kind of doing, they could have picked one from many, many sort of clonal, soil-living earthworm species that would, A, actually eat the soil that's got the toxin in it and give you a better indication of whether your toxin is doing its thing. And also, they'd all be genetically identical, so you could have more reliable tests. So yes, there are a lot of species that clone themselves or self-fertilize, and we should be looking at those a lot more in science than we do. There's that PhD in earthworm ecology coming up. There you go. Hi. Oh, sorry. Oh, sorry.
In your view, what is one thing we could do to improve the soil for these sort of creatures, and what's one thing we should maybe stop doing that's making life worse for them?
Good question. Okay, one thing I really wish people would stop doing is putting astroturf in their gardens. Plastic lawns, just please, if anyone has one, go home and recycle it or something, and then grow. Not just from the fact that it stops organic matter from getting into the soil, which is what you really want. You know, organic matter, don't disturb the soil, let it be. Yeah, that would be the best thing. And yeah, rip up the astroturf if you can, and just let it go. The lack of disturbance and increasing organic matter, perfect for soil life. That's what we want to do.
Thank you for the talk. It was great. I'm here. Sorry.
Oh, okay.
Is the New Zealand soil also has endemic species that you cannot find anywhere else in the world?
So many. Yeah, so New Zealand is incredible for what I do. I love being here as a soil ecologist. It's estimated around sort of 80% of the invertebrates in New Zealand are endemic anyway, and that's the same in the soil, probably even more so in the soil. Yeah, there's so many I would have liked to have included in the talk. There's about 200 native species of earthworm so far, but there's going to be way more than that, but no one's describing them. There's been about 20 introduced European species of earthworm, but about 200 native ones. But then when we look at the other things like the springtails, there's some giant springtails in New Zealand, which can be, I say giant, they're not going to destroy Tokyo. They're like they're like a centimetre and a half, but that's big for a springtail. There's only 5 species of those in the wild, and they're found here in New Zealand. Yeah, New Zealand's amazing for this stuff, but there's just not enough people looking at it. So if you're inspired and you want to be a soil ecologist, please do. It's an open goal, but there is no funding. That's the rub. Do you want to come up here?
Thank you, Frank. It's maybe a hard question, but do you have a favourite soil invertebrate? And if so, which one is it?
Oh, that's really hard.
No, sorry.
I have to just pick one. The question was, do I have a favourite soil invertebrate? Well, so the giant springtails in New Zealand are definitely up there. And I actually campaigned for them to be Bug of the Year 2 years ago. Do you know, hands up if you know about the New Zealand Bug of the Year contest? No. Okay. For everyone else, there is a New Zealand Bug of the Year contest. It's run every year. I'm going to put giant springtails back in the running next year. So you have all, by being here, promised to vote for the giant springtail. Okay? Yeah, cool. That's a good question.
And are there many soil ecologists before you? Like, can you tell, oh, this species is disappearing, this species appearing? Or?
Yeah, I mean, actually Darwin was the first, well, one of the first soil ecologists. Aristotle was probably the first soil ecologist. And then a bit later, Darwin came along and wrote a book on earthworms. So if you don't know about that, Darwin wrote his last book was about earthworms. It was actually outsold on The Origin of Species the year it was published, and then he died. But it was his life's work, actually. It was about earthworms. New Zealand's actually got quite an interesting pedigree in soil ecology. So a lot of the keys and a lot of the early work on earthworms and springtails was done in New Zealand back in the sort of 50s and 60s. There was actually quite a lot of funding in the CRIs, and people were allowed to do whatever they wanted. And when scientists are given free rein to go and do what they want, they do wonderful things like write keys to identify springtails and earthworms. We're in a slightly different climate now, so obviously that's trickier. The truth is, not really. We don't really know if stuff's declining or not. There's been a few studies in Europe where there's a bit more funding for it and a bit more history going back in that area. And we do think that there is a general decline in earthworms and other, like there is in other invertebrates that we see above ground, like insect decline. With land intensification and the use of pesticides and all those chemicals, like a lot of the things that people use for deworming cattle actually affect earthworms as well. And they go through a cow pretty quickly, and then they go straight into the soil, and the earthworms eat that. So yeah, they do seem to generally be in decline, but there's not enough studies into that really.
Thank you. That's all the questions we have time for. But definitely come and talk to Frank afterwards if you have more. Let's give him another round of applause.